Right now, in the dead center of our galaxy, there is a ghost. It is an invisible titan, a gravitational anchor holding hundreds of billions of stars in a frantic, eternal dance. We call it Sagittarius A star. For decades, it was just a mathematical phantom, a dark spot on our maps. But today, we know it's a supermassive black hole with the mass of 4.3 million suns. To understand that scale, imagine the average star is a single grain of salt. If you put that grain on a table, Sagittarius A star would be a 2-kilogram watermelon sitting right next to it. It is the ultimate heavyweight of the Milky Way, compressed into a space smaller than the orbit of Mercury. Yet, despite its terrifying power, it's also remarkably small. Its event horizon, the point of no return, is only about 12.7 million kilometers in radius. That is 18 times the size of our Sun, but if you compared it to the giant star Arcturus, the black hole would actually be 40% smaller. It's a paradox of nature. Massive weight, tiny footprint. But the center of our galaxy is not a quiet place. It is an extreme environment where the laws of physics are pushed to the breaking point. Astronomers have recently discovered a class of bizarre objects near the core, labeled G1 through G6. These things look like clouds of gas, but they behave like stars. When they get close to Sagittarius A star, the gravity stretches them out like cosmic taffy, tearing at their outer layers. But then, something incredible happens. As they move away, they snap back into shape. It's as if something solid is hiding inside those clouds, holding them together against the ultimate predator. Scientists believe these might be binary stars that were forced to merge into one giant, dusty hybrid by the black hole's chaotic influence. We are watching a cosmic demolition derby, where stars are being crushed, blended, and reshaped every 1,000 years. And while we think we know what Sagittarius A star is, some researchers are starting to whisper a more unsettling theory. What if it's not a black hole at all? What if we are looking at a dense core of dark matter that is simply pretending to be a singularity? The math says it's possible. And if they're right, it changes everything we thought we knew about the foundation of our galaxy. But as massive as our central black hole is, it is a mere child compared to the monsters lurking in the deep universe. In the next part, we're leaving the Milky Way to find the true kings of the void, objects so large they make our entire solar system look like a speck of dust. But if Sagittarius A star is the watermelon on your kitchen table, we are about to step into a room where the watermelons are the size of skyscrapers. Meet M87 star. This is the monster that made history in 2019 as the first black hole ever caught on camera. It sits 54 million light-years away in the heart of a giant elliptical galaxy, and it makes our local black hole look like a toy. M87 star weighs in at over 6.5 billion suns. Its event horizon is a staggering 19.2 billion kilometers wide. To put that in perspective, if you placed it in the center of our solar system, it wouldn't just swallow the sun and the Earth. It would engulf every single planet, the entire Kuiper Belt, and still have billions of kilometers to spare. It is 1,500 times more massive than the Titan in our own galaxy. But even this giant is just a middleweight in the cosmic hierarchy. In the deep reaches of the universe, 18 billion light-years away, sits the undisputed heavyweight champion, TON 618. This is not just a black hole. It is a force of nature that breaks our understanding of scale. It has the mass of 66 billion suns. Think about that number for a second. 66 billion. Its diameter is 390 billion kilometers. That is 40 times the size of Neptune's entire orbit. If you were flying a spaceship at the speed of light, it would take you weeks of nonstop travel just to cross its shadow. It is so massive that it effectively has the mass of an entire small galaxy, all crushed into one single, terrifying point in space. And here is the part that will truly mess with your intuition. You'd expect these monsters to be the densest things in existence, right? Wrong. Physics gives supermassive black holes a very strange property. As a black hole gets more massive, its volume grows much faster than its mass. This means that giants like M87 or TON 618 actually have an incredibly low average density. In fact, many of these giants are less dense than water. If you could find a bathtub big enough to hold them, these cosmic terrors would actually float. If you were drifting toward the event horizon of a 66 billion sun monster, the tidal forces wouldn't even crush you. You wouldn't feel a thing. You could cross the point of no return and not even realize you were doomed until you were already deep inside the trap. But there is a problem. TON 618 shouldn't exist. According to our standard models of how black holes eat, there hasn't been enough time in the entire history of the universe for a black hole to grow that large. It's as if we walked into a nursery and found a fully grown, 7-foot-tall athlete sitting in a crib. Something is missing from our equations. Some black holes are breaking the laws of physics and growing 13 times faster than they should. In the next part, we're going to look at the Eddington limit, cosmic speed limit for growth, and the terrifying moment when a black hole decides to take 2 bites out of the same star. For a long time, we thought black holes were the ultimate messy eaters. We pictured them as infinite vacuum cleaners, sucking up everything in their path without hesitation. But the truth is much more polite. Actually, compared to human standards, most black holes are on a permanent diet. Take M87 star. If it were an 80-kilogram human, it would be eating just 1 single grain of rice every million years. Even our own Sagittarius A star only eats a grain of rice every 100 million years. Why? Because of a fundamental law of physics called the Eddington limit. Think of it like a massive, roaring bonfire. To keep the fire going, you want to throw in more wood. But the more wood you toss into the flames, the hotter and brighter the fire gets. Eventually, the heat and the light become so intense that they actually push you back. You can't get close enough to add more fuel. This is exactly what happens around a black hole. As matter falls in, it heats up and releases massive amounts of radiation. This light pressure pushes outward, fighting against the gravity pulling inward. It's a cosmic stalemate. There is a maximum speed at which a black hole can swallow matter, before its own light starts blowing its dinner away. But here is where it gets unsettling. We've found monsters that simply ignore the rules. Japanese researchers recently discovered a quasar in the early universe that is growing 13 times faster than the Eddington limit allows. It's breaking the speed limit of physics. It's as if the bonfire has been temporarily turned off, allowing the black hole to gorge itself in a violent, jumpy growth spurt. This might be the missing link. It explains how these titans grew so large so quickly after the Big Bang. They aren't growing steadily. They are growing in terrifying, hyperspeed bursts. And it's not just gas on the menu. Sometimes, a star wanders too close. We call this a tidal disruption event. The gravity is so strong that it pulls harder on the front of the star than the back, stretching it into a long, thin noodle of plasma before shredding it completely. But in 2022, we saw something that shocked the scientific world. A black hole in a distant galaxy took a bite out of a star. We saw the flash of light. We assumed the star was gone. But 2 years later, it happened again. The same spot, the same flash. The star had survived. It was only partially shredded. It managed to escape the first encounter, looped around on its orbit, and came back for a second round of punishment. For the black hole, this wasn't a meal. It was just a snack. We are realizing that our models of how these monsters eat are far from complete. They can bite without swallowing. They can grow faster than light allows. And they can hide secrets that challenge the very nature of reality. In our final part, we're going to step into the most dangerous territory of all, the information paradox. We'll look at what actually happens inside the event horizon, and the mind-bending theory that everything we see in the universe might just be a hologram, projected from the surface of a black hole. But as we gaze at these titans of the void, we eventually hit a wall where even our best math starts to scream. It's called the information paradox. There is an old saying in literature: manuscripts don't burn. In the world of physics, this is a fundamental law. Information, the blueprint of every atom, every star, and every human life, is supposed to be immortal. You can burn a book, but if you could track every molecule of smoke and ash, you could technically reconstruct the story. Black holes, however, seem to break that rule. For years, we thought that once something fell into a black hole, its information was deleted from the universe forever. And then came Stephen Hawking. He discovered that black holes aren't permanent. They slowly leak radiation, evaporating over trillions upon trillions of years. But the radiation they send back is generic. It's just random heat. It doesn't tell us if it came from a star, a planet, or a library. If the black hole vanishes, and the information is gone, the foundation of physics collapses. This led to a mind-bending proposal known as the holographic principle. Imagine the event horizon isn't just a shadow. Imagine it's a cosmic hard drive. According to this theory, when an object falls into a black hole, its three-dimensional self is lost, but its information is painted onto the two-dimensional surface of the horizon. Like a hologram on a credit card, the flat surface contains all the data needed to describe the solid object. This suggests a terrifying and beautiful possibility. Our entire three-dimensional universe might just be a projection. We could be living on the surface of a higher dimensional reality, And the black holes are the only places where we can see the pixels of the code. But what happens if you survive the fall? What lies at the very center? Einstein's equations point to a singularity, a point of infinite density where time and space simply end. It is a dead end for physics. But modern theories, like loop quantum gravity, offer a different exit. They suggest that the point isn't infinite. Instead, it's a big bounce. As matter is crushed to its limit, the fabric of space becomes so dense that it pushes back. The black hole doesn't just sit there. It eventually explodes in the distant future as a white hole, a fountain of light and matter pouring into another part of space-time. Some scientists even believe that every supermassive black hole is a nursery. Inside TUN 618, or Sagittarius A star, the big bounce might have already happened, creating an entire new baby universe as rich and complex as our own. We might be living inside a black hole right now, blissfully unaware that we are the result of a collapse in another parent universe. Whether they are guardians of dark matter, holographic projectors, or gateways to other worlds, supermassive black holes remind us how little we truly know. They are the ultimate frontier. They are the places where the universe keeps its most guarded secrets. We started this journey in the heart of our own galaxy, looking at an invisible titan that anchors our home. We traveled to the edge of reality to meet monsters that can swallow entire solar systems. And in the end, we found that these holes in space might be the very reason we exist. The void is not empty. It is teeming with possibilities. Remember, even in the absolute darkness, there is a story waiting to be told.